before we get into the bulk of what this unit is about, which is rational functions, we're going to kind of back up a little bit and talk about a couple concepts that you should have learned in Algebra 1. That's direct variation and inverse variation. Now, the simplest way to think about direct variation and inverse variation is this. In direct variation, you have two variables. If one of the variables increases, the other variable is going to increase as well. And if the variable decreases, that's going to result in the other variable decreasing. An inverse relationship or an inverse variation does the opposite. As one value increases, the other value decreases. Well, there's a way for us to write those relationships in a mathematical sequence. So we're going to focus on that in this first lesson here. So we'll start with direct variation in this video. Now you can see just by definition it's a relationship between two variables in which one has a constant multiple of the other. If you look at that from the formula sense, you'll see that y equals kx. It almost looks like a linear function with k acting as the slope. Well, in a lot of ways it is. The k is what we call the constant of variation. And of course you remember that the slope is a constant rate of change. So those two things are kind of similar. So you can think of the k and the m, so to speak, as being the same thing. Now, what we want to do is we want to learn how to write this k in terms of x and y. And so if we move the x over to the other side, we can see that k equals y over x. And this is very good for us because this is in a ratio form. And anytime you have a ratio, you can actually write that ratio as a proportion to compare it to another y over x value. And this will help us to find any missing values in a direct variation relationship type problem. So let's take a look at how that would kind of play out. I'm going to do this. I'm going to work sample problem number 1 for you and set it up so you can see it. And then I want to see you try to work sample problem number 2 on your own based off what you see in sample problem number 1. So, alright, it says use a proportion to solve a direct variation. It says suppose y varies directly with x. Well, when y varies directly with x, we can basically say that y equals to kx, or as we saw earlier, that k equals to y over x. So if we already have a y value of 9 when x is equal to negative 15, we can say that we can create that 9 over negative 15. Now think of that as your scale factor, your constant of variation, your slope, whatever you want to do. But the last part of this question asks, what is y when x equals to 12? And this is where the proportion comes into play. So 21. So x equals to 21. We want to know what the y value is when x equals to 21. And there's your proportion. Now, you should remember from Algebra 1, maybe even all the way back to pre-algebra, that whenever you have a proportion, which is simply two ratios that are equal to each other, you use cross multiplication to solve for this. So we'll go ahead and do that. So that's negative 15y equals to 189, and y equals to negative 12.6. I went ahead and rounded it into a decimal. If you left it in fractional form, that's fine. Okay, so what I'd like you to do is sample problem number 2. You're going to be using a direct relationship, but this time it's in a word problem format, and you have to come up with the two variables on your own. Okay, so let's take a look at this. It says commissions vary directly with sales. So let's just go ahead and put our direct variation formula there. Now we have y and x, but this time we want to say something that represents commissions and sales. So we can actually change this to C for commissions. We'll still use our K, and we'll use S for X. So let's take a look. It says for $1,000 in sales, the commissions is $85. Well, what we can do here is we can either set it up in proportion format, or if you like, you can actually find the scale factor value for K. So you can either do it like sample problem number 1, and if you did, that's perfectly fine. Or I'm going to show you another way to back into this. in this method. So we can say that for $1,000 in sales, we have $85 in commissions. So $1,000 in sales. So basically, our K here is going to equal to 85 over 1,000. Or if we want to break that down, that's 0.085. Now what we can do, it says the commission, what is the commission for 2,300 in sales? We can go back to this C, and now we have a value for K, 0.085, and then we want 2,300 in sales. So our commission for that would be $195.50. Now, what we've done here with our K, this ratio of $85 per $1,000 sales is our ratio. That K actually represents a commission rate, a constant rate or a constant of variation. And so we could say that basically this is 8.5% commission rate on every sale that they actually make in this particular problem. So that is a good start for direct variation. In the next video, we'll talk about inverse variation.